Hello and welcome back my YouTube channel MS Maths. In this video, we are going to discuss about Z transformation. Basically, what is the Z transformation? We will take a basic idea and after that we will discuss the basic formula and the derivation of the formula by using the definition. Basically, first of all, we have to know about that what is the transformation. Transformation is nothing but if we have a format in a particular in a single variable or in a particular variable, then we will convert into a other variable and other space, you can say, and in that space we can solve easily by the things by the using the properties and by using the formula. And then after that after that solving the things, and we can convert back, like get back into the our main or original, original form. Basically, the transformation meaning is that we can transform, we can convert a variable to other variable and solve and get back to the our original form. So basically, Z transformation is one of the transformation, like Laplace transform, Fourier transform, and Z transform. In this transform, basically we are we will we have a variable that is nothing but a complex variable, Z variable. So we will convert all the things into a complex variable in a complex space and then solving the all the things and get back into our original real space. So the definition of this transformation, and we will see in this video. So now come to the definition. Basically, Z transformation. Basically, all the transformations are used for time function. We have a form in a time, and we can convert into a like linear time invariant discrete system. Okay, so basically the transform of the applicable, that transform is applicable for linear time invariant discrete system. So first of all, we know about that what is the discrete system. Discrete system is nothing but a function which is, like, you can say pointwise continuous, not a uniform continuous, or you can say it is like not a continuous function like this. Like I'm saying, just I'm taking the example of sin x. This is the continuous function, or simply we can take like this signum function like this. Okay, so basically this is a like a discrete function. Okay, so this type of function is known as discrete function, or we can say like this type of function. It is not, it is continuous. Yeah, it is pointwise continuous, but it is not like in a way continuous. In a there is no continuity like in a flow. Okay, basically discrete system, for a discrete system, and with respect to time. With respect to time, if we have a time on the x-axis, then this type of system is known as time invariant discrete system. For this is the applicable. So basically, the main use of this transformation equation is in a signal analysis and signal like the transitions and all these things, and to calculate the signal frequency. And in that case, we'll use the Z transformation. Basically, Z transformation is applicable to the discrete system, and we can solve the difference equation by using the we had solved the like differential not sorry, not difference equations by recurrence relation. But now we can solve the difference equation by using the transform, Z transform. Okay, so now come to the definition. So definition is says that if you have a function fx, or you can say fn, a function, we can take a fn function, or usually in some books the abbreviation is used for this, that is the un. Be a sequence, because a sequence is nothing but a discrete system, time invariant discrete system, and we will take a discrete system. So basically un be a sequence defined on a discrete values, a discrete value like n equals to 1 2 3. Okay, so basically define on a discrete values for for the different terms, we have a different values. Then we define the Z transformation on the Fn. It is nothing but a Fx, or we can take Un as the function of the complex variable. We will convert all the function into a complex space and complex variable. Then we solve and get back into the our main or original form of the function. So basically we have this type of function, like summation n equals to 0 to infinite f of x z, it's not f of x, it is f of n. So that is f of n, like we are using the n abbreviation here. So it is for f of n, and you can take like un also. So it is a un z power n minus 1, provided the infinite series converges. This series and this series must be convergent. If it is not convergent, the Z transformation is not applicable, or definition of Z transformation gets false. Basically, provided the infinite series, this infinite series must be convergent. Okay? So now the like it is the necessary condition for the Z transformation. There is like there is a series which occurs in the Z transformation must be convergent. Okay, this is the necessary condition for this. Okay, now come to this is the basic idea of the Z transformation, and this is the basic theorem, basic definition. Now come to the next. Basically, the Z transform, like this theorem or this sequence, like how can we derive this sequence? By using, how can we derive the formula? By using, simply we can solve by the complex integration. This is nothing but a complex integration on a closed contour C. So basically, like the Z transformation, the inverse, there exists an inverse also. Like if the Z inverse f of n is nothing but a f of n, and like I'm just saying, like basically Z transform is not represented by Z of un. It is the Z of un. And please note that this is the small variable. This is the complex variable, that is the Zn. Okay, please differ these two things. It is an operator Z, that is the capital Z, and something like that, something like this. This is the complex variable Z. Okay, so Z inverse f of n is nothing but a f of n, and it is also denoted by capital F of un. Okay, and I am using this abbreviation, like this notation, to perform all times the operator Z transformation. Okay, so it is nothing but a complex integration on a closed contour. So 1 upon 2 pi iota O integration, closed integration with respect to C or a contour fz z power n minus 1. Using this formula, this formula have been created. Now, next, where C is a simple contour enclosing and lies in between ZR, and there is a condition. All the ZR, mod ZR, should be greater than R. Radius, that's the radius. Basically, this is the circle, and in a closed contour, there is a must like outside the lying, enclosed and lying outside the circle. These things, they're like this, the circle and enclosed. All the Z greater than the radius outside. All the Z lying outside the, and the series or a sequence of like un convergent for this condition. Okay, there is a condition of the convergence. So this is the this is the radius of convergence, and it is nothing but a ROC, radius of convergence, and this is the reason of convergence also. Radius of convergence is R, and the reason of convergence is nothing but out of this out of the circle. Okay, so this is the all the basic concept of the Z transformation, and it is used for a frequency analysis and frequency modulation, frequency transition, and all these things. Now come to the our medical portion. Now, first of all, we have we will see that the what is the Z transformation of some basic like some basic usual some basic problems. Like we have a value, if we have something like value like a power n, how can we convert, how can we transform into Z transformation? Basically, we will see in this topic. So first of all, we are going to discuss about a power n. If the function fn is nothing but a power n, it means if we have a function fn is a power n, then what is the basically Z transform of this? It is nothing but a capital Z, it is the operator a power n. And what is the formula? We will discuss in this. Now, some formula we will use, and like this is the general definition. By using this formula, we can easily solve here. Basically, the definition is nothing but a Z power un. It is nothing but operator capital Z is equals to summation of n equals 0 to infinite un. Okay, the function is un Z power n. It is the small z, the variable, complex variable. Now, Here a is nothing, un is nothing but un is equals to a power n. Un is nothing but a power n, and putting the a power n is here, summation n equals 0 to infinite a power n z power n minus 1. Okay, minus n here. So it is nothing but n equals to 0 to infinite, and I can write like this, a by z power n. And basically here a power z, a upon z. Now we can easily expand this series like this. I am expanding the series. I am putting 0. It is nothing but 1. Plus I am putting 1. Series. It is a series. Basically a upon z power 1 plus a upon z power 2. It is nothing but an infinite GP. Okay. So what is the value of the infinite GP? And the sum of the infinite GP is nothing but Sn is equals to, if 1 plus a square, it is an infinite GP, and that is nothing but 1 upon 1 minus r. R is, sorry, a upon 1 minus r. A is nothing but here a is equals to a means, here a means like the first term is the a1. A1, it is the first term. So 1 upon 1 minus a. Sum is 1 upon 1 minus a for this series, this infinite series. It is nothing but 1 upon 1 minus a by z, and I can write this is nothing but z upon z minus a. So the z transformation of a power n is nothing but z upon z minus a. Now here I'm taking just a special case. If a is 1, it means we can calculate the z transform of 1. What is the z transform of 1? It means that if a is 1 and un is nothing but 1 power n, and it is nothing but 1. Okay. Now here 1 z power like z1. So basically a is 1, and all the things are all like it is common, and we can simply put here. Because of that, we know that this is nothing but z upon z minus a, and a is nothing but 1. So it is nothing but z upon z minus 1. So the z transform of the 1, that is the z upon z minus 1. Okay. So by this, we can easily calculate these types of general, and you can use and you can remember all these things and all the basic formula to apply into the our next problem, or apply into the our. Basically we can easily put here from, if you get any if you get a power n in something like this, like all types of question, then you can directly put here. Okay. So now come to the next question, and next question is the z e to the power iota nx is equals to, the z transform is equals to uh, z upon z minus e to the power iota x. So how can we calculate this? So basically we know that this is the like the theorem of the definition. Basically now come to the next question. So next question is here, z transform of the e to the power iota nx is equals to z upon z minus e to the power iota x. So by using the definition, we can compare this like un is nothing but e to the power iota nx, and I can write e to the power iota x power n. And on comparing a power n, because of that, we know that the z transform of z transform of a power n is equals to, z transform of a power n is equals to z upon z minus a. So we can easily put here, like if a is e to the power iota x, then z transform of e to the power iota x power n is nothing but z minus e to the power iota x. So this is the transformation of the e to the power iota nx. Now we can find the like formula, or we can find the transformation of transformation of cos nx and sin nx by using this formula, because we know that the Euler's formula for this is the e to the power iota nx is equals to cos of nx plus iota sin nx, and also e to the power minus nx is equals to cos of nx minus iota sin nx. Basically by separating imaginary part and real part, and we can easily calculate these two formula also. So now here the z transformation of e to the power iota nx is nothing but z upon z minus e to the power x. And we can rationalize this, and we can rationalize the imaginary part only. So to rationalize the imaginary part, we have to convert only the sign of the like the sign of only imaginary part, not the whole term. So we'll multiply this thing minus iota on z minus e to the power minus iota. It is not need to convert the sign, not need to change the sign of this term, because we just want to convert, we just want to rationalize this in the imaginary part only. So it is the z minus e to the power minus iota x on z minus e to the power minus iota. Okay, basically it is nothing but z into z minus e to the power minus iota x upon, now on multiplying this term, z into z, okay, z square minus, or taking minus common, this thing z square minus z, this, okay, minus z e to the power minus iota x plus e to the power iota x and plus 1. So by this we can write z into z minus e to the power minus iota x upon z square minus z. It is nothing but cos 2 cos of nx, 2 cos of x basically. If I am adding both of these, like it will get cancelled, and that is nothing but a 2 cos of nx. So it is basically 2 cos of x. Okay, there is no n, so basically we can write 2 cos of n plus 1. Now we can easily and also we can put here, we can here Euler's theorem, that is nothing but cos of x. Okay, this is the minus, so it is cos of x minus iota sin x. So basically the imaginary part I can remove, that the z of multiplying this is in multiplication, not multiplication, minus. So basically z minus cos of x and minus iota into z sin of x upon nx. Okay, is the z minus x, okay, z square minus z 2 cos of x plus 1. Okay, plus 1 is not here, is plus 1. Basically by on comparing this term, like z transform of cos of nx, because it is cos of nx real part, on comparing the real part only, you will get z minus cos of x upon z square minus z 2 cos of x plus 1. Okay, this is the real part and this is the z transformation of cos of nx, and the imaginary part is nothing but z sin of x upon z square minus z into 2 cos of x plus 1. Okay, the denominator part is same on separating the real part and imaginary part together. Okay, so basically this is the z transformation of cos of nx and sin of nx both. You can easily calculate by this. Now come to the next one. Next one is if n, like if there is a un is nothing but n, it means n power n, n power 1, n power 2, n power 3, then how can we calculate? So basically for this, by using the definition and on comparing, firstly on comparing, un is nothing but n, and also we can write this formula here. So a power n is z upon z minus a. So basically, like the definition is says that the z transform of n is nothing but summation of n equals 0 to infinite un. Okay, so it is a un is n and z power minus n. So I'm taking just like z on multiplying here z over z. So by taking this, I can write z, and by taking this z power minus 1 z, okay, by taking z over z, and by taking this z outside, z summation n equals 0 is n sin n minus 1, and this is the z summation n equals 0, and I can write n z of n, like minus n plus 1. Okay, now by this we can easily substitute this one z, and this is the nothing but d by dz of, and I can write minus d by dz of z power minus n, because sorry, summation also here, n equals 0 to infinite, also to infinite, and it is nothing but z power minus n. If I am doing the differentiation of this, minus n is here and z power minus n minus 1. This term will get, but this minus is also extra here. So I am multiplying just minus here, that minus, that minus, minus plus, and we will get back this term. Basically, we can write this term, and it is nothing but minus z d by dz of z transform of n, z transform of it is not z transform of 1, because 1 is here, z transform of 1, and we know that z transform of 1 is nothing but a is 1, so z over z minus 1, it means it is minus z d by dz d by dz 1 upon z minus 1. So basically it is 1 upon x. The differentiation of 1 upon x is minus 1 upon x square. So basically minus z is here, minus 1 upon z minus 1 whole square is here. So basically this is z upon z minus 1. So this is like the z transform of n power 1 is nothing but z upon z minus 1 whole square. Now come to the, like, if we have zn square, zn cube, zn power 4, then by using this we can easily calculate all this. These are the general formula, and we can remember this and we can directly put into the question. But what, like, how can we calculate all the things easily? So there is a general formula. This is the general formula: z power n power p. If we have z power n power p, then we can easily calculate like this. I'm taking just like example, n equals 1. Sorry, p equals 1. P equals n power p. So p equals 1 minus z d by dz. Then z transform of x power 1 minus 1. It is nothing but z transform of 1, and we have calculate this thing is here. Okay, so basically we can easily calculate like this. So these are the basic formulas we have calculated, like z power, like z transformation of a power n is nothing but z upon z minus 1. If a is 1, then the z transform of 1 is nothing but z upon the complex format, complex variable. Then I can write like curly script z is z minus 1. Okay, now e to the power iota nx. Also, a is e to the power iota x. So it is nothing but z upon z minus a, and a is e to the power iota x. Similarly, cos of n, like you can see here, the denominator, like the denominator part is remains same, because this is nothing but the real part. This is the real part, and this is the imaginary part of the e to the power iota nx, like z transformation of e to the power iota nx by rationalization the imaginary part. Okay, and z power p, it is nothing but the general term we have discussed, and these are the formula for n square, q plus n cube, and n power 4. So it is the general term, and you can see the pattern also here. So like you can comment the pattern, what is the pattern should be in these types of terms. You can comment and you can see in the comment box. So thanks for watching my video. Keep watching MS Maths and such type of videos. You can subscribe my channel, and please support the channel, share the video. Thank you. Bye bye.